Okay, so let's have a look at question 4b from the 2014 National 5 Physics paper. It says, when looking into a calm water behind the pier, the student sees a fish. So this question relates to the previous question where the student was fishing and there were waves coming in. So now the water's calm and the student sees the fish. Unfortunately, they don't have their rod with them this time, so they can't catch it. But let's have a look at the question nevertheless. It says, complete the diagram to show the path of a ray of light from the fish to the student, and it should include the normal in your diagram. An additional diagram, if required, may be found on page 31. So if you want to do the diagram again, you make a mistake or whatever, then you can do it later on in the question paper. So it says that we must have a normal line, so I'm going to add a normal line in here just with my pen. The normal line has to be at right angles to the water. So there we have a right angle. You don't need to draw the right angle in, of course, but it's the boundary between the air and the water, and of course you may well want to do this with a ruler. So anyway, what's going to happen now is the light from the fish is going to travel up through the water, and it's going to hit this normal line here. So I'm going to take, let's say, from the middle of the fish, a line that's going to travel up here to the normal line, and I'll just put a couple of arrows on it to show that that's the direction that the ray is traveling in. And then whenever it hits this junction, or the boundary between the water and the air, the light refracts. That means it changes speed, and because it's entering at an angle to the normal, it also changes direction. And when light leaves water to go from a optically dense medium to a less dense medium, it bends away from the normal line. So instead of traveling up in a straight line up here, it bends away from the normal line, away from this line toward the student. And so we'll add in now our ray of light, which travels up here toward the student's eyes, just like that. And we can add in an arrow as well to show that it's going in that direction. So that's what we should be aiming for. Light incident on the boundary between the water and the air at the normal line, and bending away from the normal line toward the student. And of course, you know what the student actually sees then is he sees I'll try and draw that again more carefully. He sees the light traveling in a straight line, so he thinks that our fish is over here somewhere, above where the fish actually is, because he believes light travels in a straight line, and so it appears to him that the fish is there, whereas in reality the fish is down here. Anyway, we don't need all of that. Just to finish it off, I'll just rub this a little bit out here. So just to be clear, that's the diagram that we're looking for.